So we will see next problem, tutorial 2, problem number 2.14. Calculate the distance between the following pairs of points. So the first part is to find the distance between these 2 points, 2, 1, 5 and 6, minus 1, 2. So first of all, we have to identify in which coordinate system it is represented. That means it is represented in Cartesian coordinates. It is in Cartesian coordinates, okay. And the second point, that means this is in the form of x, y, z. Next is represented in cylindrical coordinates. So first of all, you have to identify that. So it is in cylindrical coordinates. In cylindrical coordinates, you know, we represent it as rho, phi and z, okay. And in this is in spherical coordinates. I am not writing coordinates anyway. So in spherical coordinates are theta and phi, okay. So in Cartesian coordinates, as the first part of the problem, we want to find the distance. So the distance is equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. So you will get it as root of 6 minus 2 the whole square plus minus 1 minus 1 the whole square plus 2 minus 5 the whole square. So you will get this answer as 5.385, okay. So this is the distance between those points. Now the second part of the problem is to find the distance between the points which are in cylindrical coordinates. So in cylindrical coordinate, the distance between the points is given as square root of rho 1 square plus rho 2 square minus 2 into rho 1 rho 2 into the cosine of the angle between them, phi 2 minus phi 1 plus z2 minus z1 the whole square. So this is the formula for that. So this is equal to square root of 3 square plus 5 square plus 2 into 3 into 5 into cosine of phi 2 minus phi 1, that means 3 pi by 2 minus pi by 2, okay. Then plus z2 minus z1, that means 5 minus minus 1 the whole square, and you have to take the whole square root. So you will get this answer as 10, okay. This is the distance between the points. Next we have to find the distance between the points which are in spherical coordinates. So in spherical coordinate, the distance between the points is given as d is equal to r2 square plus the square root of r2 square plus r1 square minus 2 times r1 r2 into cosine of theta 2 into cosine of theta 1 minus 2 times r1 r2 into sine of theta 2 into sine of theta 1 into cosine of phi 2 minus phi 1. It is a long formula. So this is, you have to take this square root, okay. So anyway, I will not write like this, it's better to remove. So the square root of this term, the whole term, okay. So the square root of the whole term. So you will get this as, you can substitute d is equal to the square root of you can see our points are 10 pi by 4 and 3 pi by 4, and another points are 5 pi by 6 and 7 pi by 6. So r2 square, that means 5 square plus 10 square minus 2 times 5 into 10 into cosine of theta 2. What is theta 2? It is pi by 4. Okay, you can verify from the question. You see, this is the question actually. So it is cosine of pi by 2, cosine of pi by 6, cosine of pi by 6 into cosine of pi by 4 minus, so this is the whole term, okay, minus 2 times r1 r2. What is r1 r2? Is 2 times 5 into 10 into sine of theta 2 is pi by 6 into sine of pi by 4 multiplied with cosine of what is phi 2, that is 7 pi by 4 minus 3 pi by 4. So this one. So if you are calculating this, you will get the answer. So after calculating, you will be getting this as the total will be like this will be 125, and this term you will get it as 61.237, and the last term, that means the total term here, all this together you will get it as minus 35.35. So this will be equal to the square root of 99.113. I am getting like this. Okay, so this is the root of 99.993. So if I take the square root of this, I will be getting it as 9.95. So this is the distance between the points. So I hope it is clear to you. Thank you.